Look at this place. Sweeping blue oceans, solid continents, vast stretches of cloud cover. It feels entirely permanent, like a static rock that has always been here and always will be. But that stability is a massive illusion. For its early history, this planet was a violent, toxic wasteland, and in its distant future, it will be a scorched, dead husk. We happen to be living during a brief, incredibly lucky window in a 4.54 billion year life cycle. To support us, the planet has to maintain a highly specific set of conditions. We need liquid water on the surface and an average global temperature hovering right around 15 degrees Celsius. If the dial turns too far in either direction, the water freezes solid or boils away into space. Earth is a finite system, operating inside a fragile, closing window of habitability. About 4.5 billion years ago, there was no solid ground here at all, just a chaotic, spinning disk of gas, ice, and radioactive debris crashing together. This model illustrates a collision with a Mars-sized object named Theia. This massive impact knocked the growing Earth off its axis, giving it a 23.4-degree tilt. That exact tilt ensures incoming sunlight is distributed evenly throughout the year, giving us predictable, stable seasons. Following the impact, a relentless barrage of icy comets and asteroids pounded the surface for hundreds of millions of years. They carried massive amounts of frozen water from the outer solar system, gradually filling in the low-lying basins to form the first oceans. Still, the air was entirely toxic. To get the breathable atmosphere we have today, the planet required a massive biological accident. Deep in the oceans, tiny organisms called cyanobacteria mutated to use sunlight for energy. They exhaled oxygen as a waste product. Over massive stretches of time, this waste gas built up in the sky, creating an atmosphere that could support complex, breathing animals. This calm blue oasis was born from extreme cosmic violence and blind biological mutations. Right now, there are 3 distinct active physical engines running continuously to keep us from freezing over or burning up. This cross-section shows the deep shield. About 3,000 kilometers below our feet, a liquid outer core made of iron and nickel churns at extreme temperatures. This intense movement generates a massive magnetic field that reaches far out into space. That magnetosphere acts as a physical barrier. It deflects highly radioactive solar winds coming from the sun, stopping those charged particles from physically stripping away our atmosphere. Second is the shifting surface. The Earth's outer crust is fractured into giant tectonic plates. As they slowly collide and slide past one another, they pull carbon down into the mantle and eventually release it back through volcanoes, acting as a massive long-term thermostat. Meanwhile, the world ocean covers 71% of that rocky crust. All that water acts as a giant thermal battery, absorbing incoming solar heat at the equator and using currents to distribute it toward the poles. Finally, there is the blanket. Gases like carbon dioxide and water vapor hover in the sky, trapping just enough radiating heat to maintain that critical 15 degrees Celsius global average. If the magnetic core stops spinning, the tectonic plates lock up, or the atmospheric gases fail, our habitable window instantly slams shut. Even if those planetary engines run perfectly, astrophysics guarantees an expiration date. Earth's ultimate fate is tied directly to the life cycle of the sun. As a star ages, it exhausts the hydrogen fuel in its core. To keep burning, the sun will expand, and over the next billion years, it will shine roughly 10% brighter than it does today. That extra heat will trigger a fatal chain reaction. The warmer temperatures will accelerate the weathering of surface rocks, a process that pulls carbon dioxide out of the air. Eventually, CO2 levels will drop so low that plants will be entirely starved of their food source, cutting off our oxygen supply. Following that, the rising global temperature will hit 100 degrees Celsius. At that point, the oceans will begin to literally boil away into the sky. Because water vapor is an incredibly potent greenhouse gas, a sky full of steam will trap even more heat. This runaway effect will turn the planet into a highly pressurized, toxic oven, much like modern-day Venus. Long before the sun actually engulfs its orbit, Earth's habitable window will permanently close, leaving behind a dead, irradiated husk. That cosmic death sentence is billions of years away, but we are currently facing much more immediate, entirely avoidable threats. Human activity is rapidly tampering with the delicate carbon balance that anchors our atmospheric blanket. We are digging up ancient, buried carbon and pumping it into the sky, while simultaneously burning down the forests that naturally filter it out. Because our oasis operates on such a strict, narrow temperature tolerance, artificially accelerating the heat risks breaking the water cycle and collapsing food webs long before the sun ever does. The ground beneath our feet is not an indestructible rock. It is a rare, finite, and deeply fragile vessel. Recognizing exactly how temporary this phase is the exact reason it demands our protection today.